When we look at the different equations, we have x squared minus y squared equals 0. When we graph it, it's going to give us these two lines of diagonals with slope of 1 and -1. And essentially, if we solve this equation, we're going to get y equals plus minus 8. If we take a look at x squared minus y squared equals 0, we just get this one diagonal line with slope of 1. And that's because this is, when we take a look at the solution to this equation, it's going to be when x is equal to y, and that's only going to give us this line with slope of 1. And lastly, when we look at x squared plus y squared equals 0, we just get a dot right at the x-axis, right at the origin. And that's because the only numbers that satisfy this equation would be x is 0, y is 0. Now we can look further at this, and we can kind of see that as it slices through the cone, it asks us, well, how does this slice through the cone work? Well, if we slice vertically through the cone at 90 degrees, right through the middle, we're going to get these two diagonal lines of slope 1 and -1. And that's going to generate that solution to x squared minus y squared is equal to 0. It's to slice through the cone straight through the vertex of that cone. If we change that a little bit, okay, we can add an angle here. So this is hard to tell, but this is slicing through where it just touches it's just tangent to the outside of the cone on the bottom, and this tangent on the outside of the cone at the top. And we're going to get this straight line here. And that's what's going to be generated by the x minus y all squared equal to 0. And then lastly, if we take a look at the cone here, we can see that as x squared plus y squared equals the radius, if we decrease the radius, we're slicing through the cone closer and closer to the vertex. And at the vertex, we just get x squared plus y squared equals 0, which gives us the one dot on the origin.